In 1804, two men walked into a world that no longer exists. They wrote it down, every detail. The width of rivers that have since been drained, the depth of valleys that have since been filled, the names of animals that have since gone silent. Meriwether, Lewis, and William Clark were meticulous record keepers. The core of discovery was not a casual camping trip. It was a government-commissioned survey of a continent that the United States government had just purchased without really knowing what they had bought. Jefferson wanted data. He wanted measurements. He wanted everything written down, and so they wrote it down, including the trees. They described forests so thick that afternoon sunlight never reached the ground. They described canopies so dense that rain fell in slow, filtered curtains, barely reaching the earth below. And they described individual trees specific, named, recorded trees with trunk diameters so wide that a fully loaded wagon could not fit around them. Trees so massive that when men stood at the base and looked up, they reported losing sight of the crown in the fog before they could identify the species. Trees that required a dozen men standing fingertip to encircle. None of those trees exist today. Not one. And that should stop you cold. Because we are not talking about deforestation. We are not talking about the logging industry, clearing old-growth forest over 2 centuries of expansion. We are not talking about something that can be explained by settlers with axes and sawmills. The trees that Lewis and Clark described were not simply cut down. There is almost no record of their lumber. There are almost no stumps where they should have stood. The forests they walked through in 1804 do not appear in the geological record the way they should. The root systems are absent. The soil disruption you would expect from the removal of trees that large is not there in the way it should be. Something else happened here. And when you start pulling on this thread, when you start cross-referencing the Lewis and Clark journals with the historical record, with early American photography, with accounts from Spanish explorers, French trappers, and indigenous oral traditions, you find something that mainstream history has no comfortable answer for. You find evidence that the North American continent, as recently as 200 years ago, contained biological structures so large, so old, and so fundamentally different from anything alive today, that they suggest the world Lewis and Clark walked into was not the product of ordinary natural growth. It was a remnant, a leftover, a ghost of something that came before. If you've been watching this channel for a while, you know where this goes. And if you're new here, buckle in, because this is one of those videos that is going to change the way you look at old photographs, old maps, and old-growth forests for the rest of your life. Before we go further, if this kind of content keeps you up at night and makes you question everything you thought you knew about the world, subscribe and hit the notification bell. We post every week and the rabbit holes only get deeper from here. And drop a comment below. We want to know, after you watch this video, do you think Lewis and Clark knew what they were actually looking at? Let's get into it. The Lewis and Clark expedition departed from Camp du Bois, Illinois, in May of 1804. They traveled west along the Missouri River, pushing into territory that no European American had formerly surveyed. Jefferson's instructions to Lewis were extraordinarily detailed. He wanted astronomical observations for latitude and longitude. He wanted soil samples. He wanted descriptions of terrain, climate, mineral deposits. He wanted census-style information on every indigenous nation they encountered. He wanted detailed records of every animal, every plant, every geological feature that might have commercial or scientific value. Lewis had been personally tutored by the finest scientific minds in Philadelphia before departure. He was not a casual observer. He was trained in botany, in zoology, in cartography, in medicine. He carried instruments. He carried specimen jars. He carried a portable writing desk and kept his journal in a waterproof case. When Meriwether Lewis wrote something down, he was writing it down for posterity, for science, and for a president who would read every word. So when Lewis writes about trees, he is not speaking loosely. He is not exaggerating for drama. He is not approximating. He is a trained scientific observer making a formal record for the government of the United States. And what he records is extraordinary. In the journal entries from the Pacific Northwest portion of the expedition, particularly in the coastal regions of what is now Oregon and Washington, Lewis describes trees of a character that has no living equivalent. He notes the circumference of Sitka spruce and Douglas fir specimens in terms that translate, by modern calculation, to diameters of 15, 20, and in some entries, beyond 25 feet. Not 25 feet tall, 25 feet wide, across, at the base. For context, a standard American freight wagon of the early 19th century had a wheel-to-wheel width of approximately 4 feet. A wide wagon, loaded with cargo, might reach 5 or 6 feet across. Lewis's descriptions of individual tree trunks would have required multiple wagons parked side by side to equal the width of a single tree. These were not the tallest trees in the forest. Lewis barely mentions their height, because height was not what was remarkable. What was remarkable was the sheer physical mass at ground level, the presence of them, the weight. He describes walking through groves where the trees were so close together that the men had to turn sideways to move between them, and yet each individual tree was itself wider than any structure most of those men had ever seen, built by human hands. He describes ferns at the base of these trees that grew to the height of a man's shoulder. He describes moss on the bark that was thick enough to sleep on. He describes an ecological density, a richness, a biological productivity that has no parallel in any forest standing anywhere in North America today. Clarke's entries from the same period corroborate Lewis's descriptions. Clarke was a different kind of observer, more practical, less scientific in his framing, but equally precise. Where Lewis measured and categorized, Clarke described in terms of human utility and human scale. And Clarke's comparisons are in some ways more striking, because Clarke keeps returning to the same reference point, the size of these trees relative to human structures. He compares trunk widths to the log buildings the men had constructed at Fort Clatsop. He notes that a single fallen trunk they used as a bridge over a stream was wider than the longest wall of their winter quarters. Fort Clatsop, their winter camp on the Oregon coast, had walls approximately 20 feet long. The tree they used as a bridge was wider than those walls. Now, here is where the story gets complicated. Because if you go to the Pacific Northwest today, if you visit Olympic National Park, or the Hoh Rainforest, or the old-growth preserves in Oregon, you will find large trees, ancient trees that are genuinely impressive by any modern standard. The largest living Douglas fir in the world, the Queets fir in Washington state, has a diameter of about 14 feet. The largest Sitka spruce on record, the Quinault Lake spruce, reaches about 19 feet in diameter. These are exceptional, protected specimens that have been growing for roughly 1,000 years, some of them longer, and they are substantially smaller than what Lewis and Clarke described as common, as unremarkable, as simply the trees that were around them. If the trees Lewis and Clarke walked through were even approaching what the journals describe, then the specimens we have today, our largest, oldest, the most protected examples, are not the survivors of that forest. They are not the remnants. They are the understory. They are what was growing in the shadow of something else entirely. Where did that something else go? The conventional answer is logging. The Pacific Northwest was one of the most intensively logged regions in North American history. Beginning in the mid-19th century and accelerating through the early 20th, logging operations stripped the coastal forests at a scale that is almost incomprehensible by modern standards. The lumber industry that built San Francisco, that built Portland, that supplied the railroad construction pushing across the continent, it came largely from these forests. And it was not gentle. It was extraction on an industrial scale, with no thought for preservation, no concept of sustainable yield, driven entirely by the insatiable material demand of a rapidly expanding civilization. So the trees are gone, logged out. That is the official story. Except there are problems with that story, significant ones. The first problem is the stumps. When you log a forest, when you cut down trees of any size, you leave stumps, and the bigger the tree, the bigger the stump. A Douglas fir with a 20-foot diameter trunk, cut at ground level, leaves a stump 20 feet across. That stump does not disappear. Stumps of that size persist for centuries under normal forest conditions. The wood is dense, heavily resinous, resistant to decay. Logging historians have documented stumps from the Pacific Northwest logging era, trees cut in the 1880s and 1890s, that are still clearly visible and still largely intact today. The logging companies of that era actually used the stumps as platforms, cutting springboards into the sides of large stumps so their fallers could stand higher on the trunk to work above the swollen base. These historical photographs, and they exist, they are well documented, show men standing on springboards cut into stumps that are approximately 8 to 12 feet in diameter. These were considered large trees in the context of 19th century logging operations. The men in the photographs look tiny. The stumps dwarf them. But those stumps are not what Lewis and Clarke described. The trees that Lewis and Clarke described, 25 feet in diameter at the base, should have left stumps twice the size of anything in the historical logging record. And those stumps are not there. Not in the numbers that should exist. Not in the distribution that the journals describe. The Pacific Northwest has been surveyed extensively. It has been logged, relogged, studied, replanted, studied again. Soil scientists and foresters have walked these valleys in detail. And the consensus in the academic forestry literature is this: the old-growth forest that existed prior to European contact was extraordinary by modern standards, but the biological record does not support the existence of trees at the scale that Lewis and Clark described as common. And this is where the mainstream account quietly steps away from the question. Because the implication, if you follow it honestly, is not that Lewis and Clark exaggerated. The implication is that something happened to remove those trees before the logging era even began, before any European-American settler with an axe arrived in the Pacific Northwest. Something removed the largest trees on the continent, leaving no stumps, no root systems, no soil record consistent with their presence, and replaced them with a second-generation forest that was itself extraordinary by any modern standard, but was nothing compared to what had come before. And when you start looking at other historical accounts from the same period, the pattern does not disappear, it deepens. Spanish explorers in California described trees along the northern coast so large their hollow bases sheltered entire groups of men and horses, not one man seeking cover, but groups, with horses, inside a single trunk. The largest living coastal redwoods today include specimens with hollow bases large enough to drive a car through, and the Spanish explorers were describing something those trees are not. French fur trappers in the 17th and 18th centuries left accounts of forests in the interior of the continent in what is now the Ohio Valley, the Mississippi Valley, the Great Plains, that have been largely dismissed as exaggeration. But when you strip away the narrative framing and focus on the specific comparisons these men made, the pattern is consistent. They describe individual trees compared to church towers. In 17th century France, a market town church tower was typically 40 to 60 feet in circumference at the base. The Ohio Valley, the flat agricultural heartland where you drive for hours through corn and soybeans. French explorers in the 1600s described forests of immense hardwoods there, with individual specimens wider than any building most of their readers had ever entered. These accounts were always filed under exaggeration, until you ask why the exaggeration is so consistent, so geographically specific, so precisely described. And then you encounter the geological data. Soil core samples, taken across the interior of North America, show a period of extraordinary organic matter deposition, beginning approximately 500 years ago and ending, abruptly, approximately 2 to 250 years ago. This humic horizon is consistent with the rapid decomposition of an enormous quantity of biological material in a very short geological timeframe. Something large died across a very wide area. The organic chemistry of that layer is consistent with massive, highly resinous woody material, not grassland, not medium-sized hardwoods having a bad century decomposing quickly, together at roughly the same time. Something happened to the trees, and it did not happen slowly. Now we need to talk about what this community has been building toward for years, because this is where the mainstream and the alternative researchers part ways on this topic, and the parting is permanent and irreconcilable. The Tartaria hypothesis, the hypothesis of a global civilizational reset event somewhere in the late 18th to mid-19th century, predicts exactly this. It predicts a world that was fundamentally different from our own, a denser, richer biosphere, an ecological productivity that would seem miraculous by modern standards. It predicts remnants of that world showing up in the historical record and then vanishing from the physical world within a generation or two of the reset. It predicts historical accounts that describe impossible things, things that witnesses had no reason to fabricate, things that were reported with precise, credible detail, things that subsequent generations quietly classified as exaggeration or myth. The trees that Lewis and Clark described are exactly what the reset hypothesis predicts, and the absence of those trees, the clean, trackless, rootless absence, is also exactly what the reset hypothesis predicts. Because the reset event, as researchers in this community have documented across dozens of different lines of evidence, was not a logging operation. It was not a gradual clearing. It was something faster, something more total, something that removed biological material from the landscape in a way that left no ordinary physical residue, no stumps, no root craters, no debris fields. Something that left the soil enriched, but the landscape emptied. Let's talk about the photographs. In the latter half of the 19th century, photographers began documenting the American wilderness. The earliest landscape photographs of the Pacific Northwest and Northern California are strange, not obviously strange. But when you look at them with this question in mind, when you ask what the trees in the background tell us about the scale of the forest that existed before the strangeness accumulates, the photographs from the 1860s, 1870s, and 1880s show logging operations in forests that are clearly second growth. These are forests that had already experienced significant disruption before the loggers arrived. The trees are large by modern standards, but the men in the photographs are not dwarfed the way they should be if these were the trees Lewis and Clark described. The stumps are large, but not incomprehensible. The cut sections of timber are impressive, but not miraculous. The original forest is not in these photographs. It had already been removed before the camera arrived. And here is something that the mainstream history of the Pacific Northwest logging era will tell you, if you push it. The earliest loggers, the men who arrived in the region in the 1840s and 1850s, before the industrial-scale operations of the later century, reported that the forests they entered were full of fallen giants. Enormous trunks lying on the ground, already dead, already in various stages of decay. So many fallen giants that they impeded travel, impeded logging, created a hazard and an obstacle that had to be cleared before any productive work could begin. Fallen giants, already dead, already decaying when the first loggers arrived. Who cut them? Nobody cut them. There is no record of a pre-logging operation that felled the largest trees in the Pacific Northwest before the arrival of European American settlers. There is no indigenous tradition of mass tree felling at this scale. There is no evidence of the tools, the labor organization, or the economic motivation that would have required it. They fell on their own, before the loggers arrived, before the cameras arrived, before Lewis and Clark's journals were read with serious eyes. They fell in that 200-year window between the last reports of their existence and the first surveys that found no evidence they had ever been there. They fell, and then they decomposed, and the decomposition was rapid and complete, and it left behind exactly the kind of soil enrichment layer that the geological record documents, and it was done before the modern world arrived to ask questions about it. This is the timeline. This is what the evidence produces when you assemble it without a predetermined conclusion. Now let's go deeper, because the tree question connects to something else in the Tartaria research that most people have not considered. Columnar basalt formations, the kind you see at the Giant's Causeway in Ireland or at Devil's Tower in Wyoming, are officially explained as cooling lava contracting into regular geometric columns. For many of these formations, that explanation is adequate. But there is a subset that fits less comfortably. Formations where the internal structure shows concentric layering consistent with biological growth rings rather than the random crystallization of cooling rock. Formations that appear in locations where no documented volcanic activity has occurred. The petrification of biological structures into silica-based rock is documented science. The petrified forests of Arizona prove that biological structures can be converted, over long timescales, into mineral facsimiles of themselves. What some researchers in this space propose is that this process operated at a far larger scale than is currently acknowledged, that some of the most dramatic natural formations in the world are the converted remains of biological structures so enormous that the human mind, confronted with the final stone product, simply cannot make the conceptual leap to recognize them for what they are. If even a fraction of that is true, then the scale of what existed before the reset event was not merely a world with larger trees. It was a world with living structures that rivaled in scale some of what we currently call geology. Lewis and Clark walked into the end of that world. They were among the last people to see its remnants standing, and they wrote it down. They wrote it down carefully, precisely, with the full authority of government-commissioned scientific observers, and the record they left is sitting in the Library of Congress and in the collected published journals that you can order online or find in any university library. It is not hidden. It was never hidden. It was simply never read by anyone who was asking the right questions. Let's talk about some specific passages, because the specificity matters. On the 20th of September, 1805, in the Bitterroot Mountains of what is now Idaho, Lewis recorded an observation about western red cedar trees in the forest around him. He noted that fallen logs served as natural bridges across mountain streams, remaining elevated above the waterline on both banks simultaneously. He described their width not as a formal measurement, but as a human comparison. The fallen logs were wide enough that a man could lie down across the top and not see the ground on either side. A log requiring that description would need to be at minimum 8 feet in diameter, and that is the conservative reading. This was background description. It was the visual context for a different observation he was making about the difficulty of travel. The trees were so big that their fallen trunks created natural bridges. He mentioned it the way you might note, in a travel letter, that the roads were muddy. It was not the point, it was just the landscape. On the 3rd of November, 1805, near the mouth of the Columbia River, Clark recorded an entry about Sitka spruce trees that lines the estuary. He noted that some specimens had root systems extending so far from the base that the roots themselves formed a kind of low fence or enclosure visible above the ground, within which water pooled and small ferns grew. He noted that the enclosed root systems of these large specimens were wide enough to shelter a small camp, not a single man, a camp from wind and rain. Modern Sitka spruce root systems, on the largest living specimens, extend perhaps 15 to 20 feet from the base in all directions. The shelter potential that Clark describes suggests root radii substantially beyond that. On multiple occasions throughout the coastal and mountain portions of the journey, Lewis uses a specific and consistent descriptive phrase when encountering particularly large trees. He calls them trees of the first magnitude. This was not an emotional expression. It was a technical classification. In the botanical vocabulary of his time, trees were categorized by magnitude, similarly to how stars were categorized first, magnitude being the largest. Lewis reserved this phrase for specific specimens that warranted it, and he used it frequently, not for the occasional giant, but for tree after tree after tree across hundreds of miles of Pacific coastal forest. None of the trees surviving in those regions today would qualify for that classification under Lewis's own standards. The difference between the forest that Lewis and Clark walked through and the forest that exists in those same locations today is not a matter of degree, it is a matter of kind. We are not talking about a forest that used to be bigger and is now somewhat smaller. We are talking about two different biological realities separated by 2 centuries of time and by an event that the official record does not acknowledge and cannot adequately explain. And here is where we need to address the most common objection, that these observations are qualitative, not measured, and that extraordinary environments produce extraordinary prose. That Lewis and Clark were simply writing for an audience that needed to be impressed. This objection collapses under examination. Lewis was explicitly trained to be precise. Jefferson's instructions specifically cautioned against impressionistic description. Lewis knew the difference between a measurement and a simile. When he chose a simile, it was deliberate, and the consistency across 2 different observers with different writing styles argues strongly against individual exaggeration. Most importantly, if we dismiss the tree descriptions, we must dismiss all their observations equally. But Lewis and Clark's measurements of rivers, populations and species have been extensively corroborated. They were reliable. The burden of proof lies with those who claim otherwise. The trees were real, and they are gone. So we return to the central question: how does a forest of that scale disappear without the physical record looking like ordinary deforestation? There is a concept in this research community called the grey layer. It refers to a stratigraphic feature, a distinct sedimentary horizon that appears in soil cores from multiple locations across North America at a depth corresponding to approximately 150 to 250 years of accumulation. This layer is characterized by fine, ash-like mineral composition mixed with high concentrations of organic carbon, the chemical signature of large-scale, rapid combustion. The academic geological literature attributes different occurrences of this layer to different local causes, a wildfire here, a volcanic event there. But when independent researchers mapped this feature across widely separated locations across the Great Plains, the Pacific Northwest, the Mississippi Valley, the Ohio Valley, a different picture emerged. Not a patchwork of local events, a consistent horizon, the same depth, the same chemical signature, the same approximate time frame. Something burned, widely, rapidly, with an intensity that consumed biological material on a continental scale. And it burned at approximately the same time that the largest trees in North America disappear from the historical and biological record. The Younger Dryas impact hypothesis, which has now accumulated substantial support in the peer-reviewed literature, documents a massive biomass burning event approximately 12,000 years ago associated with a proposed comet impact. The evidence includes exactly the same stratigraphic signature that appears in the more recent grey layer. If a comet impact can produce a biomass burning event detectable 12,000 years later, then a similar but smaller and more recent event would produce exactly what the grey layer represents. This is not proof, it is a pattern, a convergence of historical accounts, geological data, biological records, and the testimony of the first loggers, all pointing toward the same thing. A world that existed and was destroyed. A forest that Lewis and Clark saw and that no human being alive today has ever seen. Because whatever happened to those trees happened completely. It left no survivors, no diminished remnants struggling back to former glory. It left a second-generation forest extraordinary, growing over in rich soil, in a landscape cleared by something that no ordinary process replicates. And 200 years later, the largest trees in that second-generation forest are themselves now mostly gone, cleared by an industrial logging operation that came in and saw, not the original, but the replacement, and cleared that too. We are now living in a third-generation landscape, a landscape that has been reset twice in recorded history, once by an event we cannot name, and once by the industrial economy of modern civilization. And the forest that Lewis and Clark walked through, the one they thought was the world, the one they catalogued as though it would always be there, was already the diminished remnant of something older, something larger, something that had already been lost once. There are researchers in this space who have spent years working through what the Tartaria framework implies about pre-reset ecology. The working hypothesis is that the biological productivity of the Earth, before the reset event, operated on a fundamentally different scale. That the trees we read about in the historical accounts were products of a biological regime with different inputs, different atmospheric conditions, different soil biology, different chemistry that allowed living structures to grow to a scale that our current world does not support. What changed? Some researchers focus on atmospheric chemistry, a pre-reset atmosphere with different pressure or carbon characteristics that allowed photosynthetic organisms to grow faster and larger. Some focus on the soil biology, a mycorrhizal network of complexity and density that no longer exists, that allowed trees to share nutrients and chemical signaling in ways that supercharged their growth. These are speculative frameworks. They are not in the peer-reviewed literature. They are the frontier of a conversation that mainstream science has not caught up to yet and may resist catching up to for a long time because the implications are too large and too disruptive to the existing paradigm. But the trees were real. Lewis and Clark wrote them down, and they are gone, and the how and why of their going is a question that the official record has never satisfactorily answered. We began this conversation with two men walking into a world that no longer exists, but let's be precise about what that means, because precision matters here. Lewis and Clark were not walking into a wild, untouched, primordial wilderness that had existed unchanged since the beginning of time. The indigenous people they met throughout that journey described, in their oral traditions, a world that had changed. A world where the rivers had once run differently, where the climate had once operated on different rhythms. Many of the nations they encountered had traditions of a great catastrophe, a fire, a flood, a darkening of the sky, a time when the world was remade, that had occurred in a time beyond living memory, but not so far beyond it that its effects were not still visible in the landscape. The core of discovery walked through a landscape that those nations understood to be a post-catastrophe landscape, a regrowth, a recovery, an aftermath. Lewis and Clark did not have that context. They walked through what they believed to be the natural state of the continent. They had no framework for understanding that the extraordinary forest they were recording was ending, that the act of recording it was, in some sense, the last act before it ended. They were scientists, doing their jobs, walking west into the unknown, writing down trees wider than wagons. And by the time anyone thought to go back and look at what they had written with serious eyes, the trees were gone. Think about what that means. The ancient, primordial, impossible forest of 1804 was not the original. It was the regrowth after a previous clearing. It was what came back after the first reset. And even that regrowth produced trees wider than wagons. Even that secondary growth was a forest of the first magnitude. What must the original have been? We are standing now in a third-generation landscape. A landscape that has been reset twice in recorded history. Once by an event we cannot name, and once by the industrial economy of modern civilization. And the forest that Lewis and Clark walked through was already the diminished remnant of something older, something larger, something that had already been lost once. The trees are not in the national parks. They are not the champion specimens maintained and celebrated as the largest living representatives of their species. Those trees, remarkable as they are the grandchildren of something they cannot imagine. They are the third act of a story whose first act ended before any camera existed to record it. And two men walked through the second act in 1804 and wrote it down. The answer to where the trees went is not in the logging records. It is not in the forestry literature. It is in the soil cores and the grey layer and the absent stumps and the fallen giants and the oral traditions of the people who were there when the sky darkened and the world was remade. It is in the journals of Lewis and Clark, sitting in the Library of Congress, describing a world that ended before the first photograph was taken, before the first logger arrived with his saw, before the first settler built his cabin in a clearing that was somehow already cleared. Trees wider than wagons. None of them exist today. Ask yourself why.